Hello students, welcome to the second PUC chemistry question paper discussion. In this session, we are going to discuss the question paper pattern, important questions for the annual examination, and also if the time permits, let us solve the departmental question paper on chemistry. First, I'll begin with the question paper pattern. This year's chemistry question paper has seen lots of changes. The number of questions in the question paper have increased to 50 and the total marks in the question paper is 140. Of course, out of 140, you need to answer only questions for 70 marks. Let us briefly have a look at the question paper pattern or the blueprint. The question paper, as all of you are aware, has got 4 parts. Part A in the question paper has only 1 mark questions. There are totally 15 questions, out of which you need to answer any 10. 1 mark questions can appear from any part of your chemistry syllabus, inorganic, organic or physical. Of course, the chapter is fixed for every question number, which we shall discuss later. But remember that there are no specific topics under which the questions appear. They can come from any nook and corner of the textbook. The guidelines say 3-dimensional diagrams must be avoided, and also the topics covered under yellow boxes of the textbook will be avoided, and the numerical values based on experimental data given in the tabular columns of the textbook will not be asked. So, except for this, 1 mark questions can appear from anywhere from the textbook. So, it is very difficult to predict 1 mark questions. 1 mark questions anna predict ಮಾಡಲಿಕ್ಕೆ ಸ್ವಲ್ಪ ಕಷ್ಟ ಇದೆ. Still, let us see some sample questions of 1 mark a little later. The second part of the question paper is part B, Roman number 2. Here you get 2 mark questions. There will be totally 10 questions, out of which you need to answer any 5. ಹತ್ತಿರಲ್ಲಿ 5 questions ಅನ್ನ ಆನ್ಸರ್ ಮಾಡಬೇಕಾಗತ್ತೆ. ಇಲ್ಲಿ ಕೂಡ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾರ್ಟ್ ಇಂದ ಕ್ವೆಶ್ಚನ್ ಅನ್ನ ಕೇಳುವುದಿಲ್ಲ. Inorganic, organic, physical, all questions will be there. But certain chapters are reserved for 2 mark, which we shall discuss. Though the particular part is not specified, there are certain topics on which the 2 mark questions will come. 1 mark questions anna predict ಮಾಡೋದು ಕಷ್ಟ, but 2 mark ಅಷ್ಟು ಕಷ್ಟ ಇಲ್ಲ. Some topics are there on which the questions will appear. Then part C of the question paper has got 3 mark questions. These come only from the inorganic chemistry part of your syllabus. You know the chapters that are included in inorganic chemistry. The chapters are unit number 6 of your textbook, that is general principles, 7 P block elements, 8 D and F block elements, 9 coordination compounds. So, 3 mark questions will appear from only these units. There are totally how many questions? There are 10 questions, and out of these 10 questions, you need to answer only five questions. The first 3-mark question in your paper, that is question number 26, will come from general principles, and 27, 28 and 29 will come from P block elements. Of course, question number 27 is reserved for group 15 of P block, 28 for group 16 and 29 for group 17. So, the 3 questions come from P block elements. The next question, that is 30th question, it is a D and F block element chapter question. 31st question also comes from D and F block. 30th and 31st questions are actually from D block elements in keltare, and 32nd question annu F block elements in the keltare. So 30th and 31st question is asked from D block elements, and 32nd question is from F block elements. The rest of the 3 questions, that is 33, 34 and 35, they come from coordination compounds. So out of these questions, certain questions are almost sure questions, which we shall discuss later. And you have to note that here, as far as possible, a question will be set for 3 mark. Splitting is avoided maximum times. Only when there is no other way, they'll split the question as 2 plus 1. Most of the times you get a single 3 mark questions, but sometimes the splittings may arise. But remember that intermixing of the units will not be done. When there is a splitting, 2 plus 1 anta question anna split ಮಾಡುವಾಗ ಒಂದೇ ಯೂನಿಟ್ ಇಂದ 2 questions ಇರುತ್ತೆ, ಬೇರೆ ಬೇರೆ ಯೂನಿಟ್ ಗಳಿಂದ questions ಅನ್ನ ಮಿಕ್ಸ್ ಅಪ್ ಮಾಡೋದಿಲ್ಲ. So it is easy for you to identify the question. Coming to part D of the question paper, this comes from the physical chemistry part of your syllabus. You know the units covered under physical chemistry. They are unit number 1 to 5, the solid state, solution, electrochemistry, kinetics and surface chemistry. The first question in part D. Of course, there are 6 questions and you need to answer 3 questions here, only 3 out of 6. The first question, that is question number 36 of the paper, is on solid state. Question number 37 is from solutions. 38 is from electrochemistry. 39 and 40 are from chemical kinetics. So, chemical kinetics is given more weightage. 41 comes from surface chemistry. Again here the intermixing of the units is not done. Most of the times the splitting of the question is done such that you get 1 3 mark question and 1 2 mark question. 3 plus 2 splitting ಮಾಡ್ತಾರೆ ಆದಷ್ಟು. Very rarely 2 plus 2 plus 1 ಮಾಡ್ಬೋದು. And here also there are some 100% sure questions and there are some most probable questions. So, scoring in this unit is, in this section is very easy. Moving on to the last part of your question paper, that is part D, Roman number 5. This part is meant for organic chemistry, the biggest part of your textbook. As you are well aware, there are many units in organic chemistry. They are unit number 10 to unit number 16. Of course, a 16th unit doesn't come in the 5-mark section. From the 16th, that is the last unit, questions come only for 2 mark, that is chemistry in everyday life, e unit in the 5-mark questions ಯಾವುದು ಬರುವುದಿಲ್ಲ. ನಿಮ್ಮ ಪಾರ್ಟ್ ಬಿ ಅಲ್ಲಿ 2 mark questions ಮಾತ್ರ ಬರುತ್ತೆ. ಸೊ ಅದನ್ನು ಬಿಟ್ಟರೆ ಬಾಕಿ ಎಲ್ಲ ಯೂನಿಟ್ಸ್ ಇಂದ ಕ್ವೆಶ್ಚನ್ಸ್ ಇದೆ. So which question number is kept for a particular chapter? Let us see. The first question, that is question number 42. This is for the haloalkanes and haloarenes unit. Question number 43 and even question number 44 are for alcohols, phenols and ethers. So there are 2 questions from this unit. Weightage given is more for the alcohol, phenol, ether chapter. 45 and 46 are for aldehydes, ketones and carboxylic acids. Adralli 45th question aldehydes matte ketones ige and 46th question carboxylic acids ige. 47th is for amines. 48th and 49th are from biomolecules. Again, majority of the questions here come from carbohydrates and proteins. Okay, weightage given for carbohydrates and proteins is more. Remaining topics like vitamins, hormones, nucleic acids get less weightage. So remember, in the last section, biomolecules, 2 questions, carbonyl compounds, 2 questions, and alcohol, phenol, ethers, 2 questions. And the last question, that is 50th question, is from polymers. So totally there are 9 questions, out of which you need to answer only 4, less than half. Okay, 9 alli just 4 questions answer ಮಾಡಲಿಕ್ಕೆ ಇರೋದು. So this is the question paper pattern and some guidelines to set the question paper. Now let us see the important topics and the most probable questions. Some are 100% sure and some are expected questions. So let us discuss those topics and let us also try to have some key points on the most important questions. So here let us go chapter wise. As I have already told you, ಮೊದಲೇ ಹೇಳಿದ ಹಾಗೆ 1 mark questions ಅನ್ನು predict ಮಾಡೋದು ತುಂಬಾನೇ ಕಷ್ಟ. So ಕೆಲವೊಂದು sample questions ಅನ್ನು ಮತ್ತೆ ನೋಡುವ, especially from the departmental question paper. But 2 mark and the higher mark questions can be predicted to certain extent. So the first unit of your textbook, that is the solid state, the weightage given for the chapter is 1 plus 2 plus 5. There will be 1 mark question, one 1 mark question, one 2 mark question and one 5 mark question. So totally 8 mark question will be there. As I already told you, there is 100% sure question from this particular unit, which is that it is question number 1, okay, or I can say the topic number 1, packing efficiency derivation. It will be asked either for the simple cube, which can also be called primitive cube, or for BCC, or can also be asked for FCC. The other name of FCC is CCP. So, out of these 3 derivations, one derivation is a 100% sure question. Now, let us see some key points regarding the solution. ಈ derivation ನ solution ಬಗ್ಗೆ ಒಂದು ಸ್ವಲ್ಪ ತಿಳ್ಕೊಳ್ಳೋಣ. Packing efficiency derive ಮಾಡುವಾಗ you have to draw the diagram, you have to give the introduction, and first of all you have to deduce an expression for the edge length of the cube. So, if you reach up till there, you will get 1 mark. So, what is the edge length for a simple or primitive cube? You know that it is A is equal to 2R, and for a FCC, it is A is equal to 2 root 2R, and for a BCC, A is equal to 4R divided by root 3. So, this step, if you can derive till here, it will fetch you 1 mark. Istu madidre, illiyavarege madidre, you get 1 mark in the derivation. And then you proceed and you write the packing efficiency formula as volume of the particle, right? Of course, the particle number varies. In a simple cube, it is only 1. In BCC, it is 2. And in FCC, it is 4. Okay, so you have to mention that particle number, volume of 1 particle or volume of 2 or volume of 4 particles in the numerator, and volume of the cubic unit cell. Is it not? Volume of the cubic unit cell in the denominator. You have to write this formula, and then you have to do the appropriate substitution by knowing the value of A, which you have already derived. So, this much carries another 1 mark. So, till here if you do, you get 2 marks. Then after calculation, you get the answer as 52.4. Of course, there is a 100 in the packing efficiency formula in the numerator, because you are expressing the value in percentage. Percentage alli value express ಮಾಡುವ ಕಾರಣ 100 ಇದೆ numerator alli. So, the final answer will be 52.4% for a simple cube, or it will be 68% for your BCC and 74% for FCC, the highest. So, this answer will give you another 1 mark. So, this is how the 3 marks are distributed. Ee tara distribute agirutte ಹೆಚ್ಚಿನ answer scheme alli. So, these are the key points regarding the first very important question of your syllabus. Going back to the important questions, note that the important questions are given in dark letters, okay, first and the second, they are made bold. So, they are the important ones actually, and 3, 4, 5, they are the other important questions, okay. They are not 100% sure questions, but there may be 2 mark questions from those topics. The next important question for 2 mark from this particular unit is density problem. The formula for density is D is equal to Zm divided by AQNA. Okay. If you just write the formula matra bardre, remember, you will not get even a single mark. Formula along with the substitution will give you 1 mark. So you have to write the formula and you have to substitute it properly. So what is Z here? Z is of course the number of particles, 1 or 2 or 4, is it not? Then what is M? It is the molar mass. It may not be given as molar mass, molecular mass ಅಥವಾ atomic mass ಅಂತನೂ ಕೊಡಬಹುದು. ಗ್ರಾಮ್ ಪರ್ ಮೋಲ್ ಅಲ್ಲಿ ಕೊಡೋ ಬದಲಿಗೆ ಯು AMU ನಲ್ಲಿ ವ್ಯಾಲ್ಯೂ ಕೊಡಬಹುದು, ಬಟ್ ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ ಇಟ್ ಆಸ್ molar mass because you know that the value is the same. Though the units differ, the value remains the same for two of them. And A is the edge length. Okay, A here is the edge length. Most of the students don't cube A. Substitute maduvaga, one common mistake that we see in the paper, answer paper, is most of them don't cube it. They just write the value of A. A matra baritira, A cube anta bariyudilla hari bariyali, athwa A cube anta baradru calculation nalli cube madodanna maritiri. That is one common mistake that we observe. And of course, Na is the Avogadro number, for which you know the value. In the question paper also, they give you the value of constants. Even if it is not provided, you know it very well. So do the substitution carefully, because formula along with the substitution will give you 1 mark. All right. Okay. And then you calculate the value and report the answer. Just the answer without a numerical unit will not give you any mark. Remember, the result must have the unit. Okay, the result must have the unit, only then you get the second mark. So this is regarding the density problems. What is the unit for density? Most of the problems you work out in CGS system. So the density unit will be gram per cm cube. Molar mass is substituted in grams and edge length A is substituted in centimeter. Even if they give the edge length in picometer, you have to convert it to centimeter by multiplying it by 10 power minus 10. You know it. Okay, so see to it that all the values are substituted in CGS and you get the unit for density as gram per cm cube. Then the other question, other important question here is either the density problem is asked or the number of particle calculation. Is it not? Number of particle calculation is asked, for which you have to write a small diagram and you have to say where exactly the particles are located. If it is a simple cube, the number of particles per unit cell will be 8 particles at the corners into 1 by 8. Is it not? So that will give you 1. For BCC, there is an additional particle at the center of the body. So that makes the total count 2. And for FCC, 1 by 8 into 8 at the corners. And also there are how many particles at the face centers? There are 6. Contribution of each particle towards a unit cell is half. So 6 by 2. Okay, plus 8 by 8. That will give you 4. You know it very well. So density or particle, number of particle calculation per unit cell is an important question. Of course, there are other questions. Differences between the two types of defects, two types of solids, and there will be questions on the types of voids. So these are the other probable questions. Okay, moving on to the next unit, that is solutions. There are 2 1-mark questions and 1 2-mark question and 1 5-mark question. Totally 9-mark questions will come from this unit. which is the sure question from this unit. It is a problem, numerical problem on any one of the 4 colligative properties. Which are those 4 colligative properties? Relative lowering of vapor pressure, for which the formula is relative lowering of vapor pressure is the first colligative property, and then you also have elevation in boiling point, depression in freezing point, and osmotic pressure. So, let us list the formulae which are used for the problem. Formula number 1 is P01 minus P1 divided by P01 is equal to W2 by M2 into M1 by W1. Okay, so all the masses here on the right hand side are in, remember, grams, is it not? And the left hand side term is a unitless quantity, is it not? So, this is the first formula. Not stands for the pure solvent. Okay, then the second formula is delta TB is equal to KB into W2 by M2 W1 in kg. Remember, here the W1, that is weight of the solvent, must be substituted in kg. Rest of the weights, W2 weight of the solute, M2 molar mass of the solute, adu grams alli irbeku, but W1 should be in kg. So, here you should be careful. And of course, what is the formula for delta TB? Delta TB, elevation in BP of the solution. So, solution na boiling point jasti, TB minus TB naught. Okay, it is TB minus TB naught. Okay, depression in freezing point ge adu ulta irutte, TF naught minus TF agutte. Okay, and a very similar formula can be written for delta TF. It is delta TF equals KF W2 by M2 W1 kg. Alright, then what is the formula for the osmotic pressure? The formula that we remember for osmotic pressure is pi V is equal to N2 RT. This is of the form PV is equal to nRT, which is your ideal gas equation. Okay, this is how we remember the formula, and then you can substitute for N2, that is W2 by M2, and then RT. Okay, so this is the formula for osmotic pressure. Again, W2 and M2 both are generally substituted in grams. Temperature, remember, should be in Kelvin. Okay. So, based on these formulae, any one question will come from the solution chapter, and most of the times they ask the problem from the first 3 colligative properties. Then there are other important topics listed in the slide, like the statements of the laws, effect of temperature and pressure on solubility of gas in liquid, then types of solutions, ideal, non-ideal, Non-ideal, there are two types, type 1 and type 2. There are azeotropes, types of azeotropes. Van 't Hoff factor I, you can expect a small a problem on its formula. There are graphs, different types of solutions, isotonic, hypertonic, hypertonic. Okay, and one more, most of the times asked question is reverse osmosis. So all these are there. 100% sure question is only one, that is the first question which we have discussed. All right, moving on to the next unit. Third unit is electrochemistry. Electrochemistry ಮೇಲೆ ಒಂದು 1 mark question ಇದೆ and ಎರಡು 2 mark question ಇದೆ. Also there is one 5 mark question. And here again you have a sure question. Question number 1, it is a numerical problem. Chapter ಇಂದ ಯಾವುದೇ problem ಕೇಳಬಹುದು, but most of the times the problems are asked on these 3 concepts, that is Nernst equation or delta G naught and the equilibrium constant K. So idra mele ಹೆಚ್ಚಾಗಿ problems ಇರ್ತದೆ. And so let us see the formulae for these problems. What is the Nernst equation for the EMF of the cell? EMF of the electrode problems are rare. Okay, generally the problems are asked on EMF of the cell. The formula is E cell is equal to E naught cell minus 0.059 divided by N, and then you have a log term, is it not? So let's formulate it. E cell equals E naught cell minus 0.059 divided by N log of, here you have got different products. Of course, raised to the appropriate powers, is it not? And then you have got reactants, again raised to the appropriate powers. You can write the formula by looking at the reaction that is given to you, is it not? If you want, you can write the general formula as square bracket C to the power C, square bracket D to the power D divided by square bracket A to the power A, square bracket B to the power B. So general formula can be written, or by looking at the reaction you can frame the formula and write. So here you have to know how to write the value of N. N hege baritira? Equation will be given to you, the cell reaction equation. Based on that you can write the formula. So if you have a reaction of the type Zn plus Cu2 plus giving Cu plus Zn2 plus, then what is the value of N? You see the change in oxidation state of zinc. It is 0 here and here it has become plus 2. So the change is 2 minus 0, that's 2. Copper ಗೆ ಕೂಡ ಅದು ನಿಜ. Copper ಗೆ ಇಲ್ಲಿ 2 plus ಇದೆ, right hand side ಅಲ್ಲಿ 0 ಇದೆ. So 2 minus 0 will give you 2. So this is how we find out N in the problem. And sometimes E naught cell will not be directly given. E naught cell ಅನ್ನ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕೊಡದೆ ಹೋಗಬಹುದು. In such cases you have to write the E naught cell formula as E naught RHS, right hand side electrode na potential, minus E naught LHS, okay, left hand side electrode na potential. Right hand side electrode, remember, is the reduction electrode and LHS is the oxidation electrode. ಸೊ ಈ ನಾಟ್ ಸೆಲ್ ಅನ್ನು ಈ ಥರ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾಗಿ ಬರ್ಬೋದು. ದೆನ್ ವಾಟ್ ಆರ್ ದ ಅದರ್ ಫಾರ್ಮುಲೆ that help you solving the problems? It is delta G naught is equal to minus NF E naught. Gibbs energy of the reaction is minus NF E naught. Okay. F is Faraday's constant, 96,500 coulomb, and E naught is nothing but EMF of the cell. So based on this, the problem may be asked, what is the unit for E naught? E naught is given in voltage, so the result E cell annu kuda neevu voltage nalle express ಮಾಡಬೇಕು. ಡೆಲ್ಟಾ G naught ನ ಯೂನಿಟ್ ಏನು? ಜೌಲ್ ಪರ್ ಮೋಲ್. Remember, in a 3-mark problem, 1 mark may be given for the formula and the 2nd mark for the substitution, and the 3rd mark will be for the result along with the unit. Okay, what is the formula for calculating equilibrium constant? Equilibrium state alli nimge gottide E cell becomes 0. E naught cell remains as such. Then rest of the terms are written as before in the Nernst equation, but product by reactant term at equilibrium becomes equilibrium constant. Is it not? So this is the modified formula for calculating equilibrium constant. Idanna by heart ಮಾಡುವ ಅಗತ್ಯ ಇಲ್ಲ. Nernst equation ಅನ್ನು ನೆನಪಿಟ್ಕೊಂಡ್ರೆ ಸಾಕು, ಅದರಿಂದಲೇ ಬರಿಬಹುದು. Okay. So problems based on these formulae will be asked from electrochemistry. Then there are other important questions. SHE, standard hydrogen electrode, conductivity, molar conductivity, their relationship, how do they vary with dilution, Kohlrausch law and the problem, and anode and cathode reactions of various cells, the reactions in corrosion, the reactions in hydrogen oxygen fuel cell. Okay, so anode cathode reactions can be asked for 2 mark. Next unit is chemical kinetics. There is only one mark question, and there are 2 5-mark questions. So there is a small correction in the slide. It is 5 plus 5, not 15. Okay. So 1 mark question, and there are 2 5-mark questions. So totally it will be for 11 mark. And illi kuda ondu 100% sure question ide, adu derivation. Integrated rate equation in a derivation. ಒಂದ 0 ಆರ್ಡರ್ಗೆ ಕೇಳ್ತಾರೆ, ಇಲ್ಲ ಫಸ್ಟ್ ಆರ್ಡರ್ಗೆ ಕೇಳ್ತಾರೆ. Also, since this time there are 2 questions from kinetics, there is one more question which you can say is almost sure. ಅದು ಯಾವುದು? Problem on activation energy ಆಗ್ಬೋದು, ಅಥವಾ half life ಆಗ್ಬೋದು, or first order na rate constant ಮೇಲೆ. Okay, half life and first order na K ಮೇಲೆ problem is almost sure. Okay, so first let us discuss the integrated rate equation derivation. Zero order ge ನಾವು ಫಸ್ಟಿಗೆ differential rate equation ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೇವೆ. Is it not? And then we integrate it. We find out the integration constant value. After substituting, we get the integrated rate equation. First order ge kuda ide ಮಾದರಿಯಲ್ಲಿ ಏನು ಮಾಡ್ತೇವೆ? Differential rate equation ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ ಅದನ್ನು ಇಂಟಗ್ರೇಟ್ ಮಾಡಿ ಪ್ರಾಪರ್ ಕಂಡೀಷನ್ಸ್ ಅಸ್ಯೂಮ್ ಮಾಡಿಕೊಂಡು ಇಂಟಗ್ರೇಷನ್ ಕಾನ್ಸ್ಟೆಂಟ್ನ ವ್ಯಾಲ್ಯೂವನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ ಕೊನೆಗೆ integrated rate equation anna deduce ಮಾಡ್ತೇವೆ. Okay, so what is the differential rate equation for your zero order reaction? It is minus d square bracket r by dt is equal to k. So if you integrate and find out the integration constant value, it comes out to be square bracket r naught, is it not? Initial reactant concentration. ಅದನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದರೆ ಕೊನೆಯಲ್ಲಿ ನಿಮಗೆ integrated rate equation sigate. What is that equation? It is k is equal to r naught minus r, of course under square brackets, divided by t. Half life in conditions anna substitute ಮಾಡಿದಾಗ you get the half life as r naught square bracket r naught divided by 2k. half life anna kuda derive ಮಾಡಲಿಕ್ಕೆ ಕೇಳಬಹುದು 2 marks ಗೆ. So this is for zero order. Then for first order you have an additional term along with k, that is square bracket r, and integration constant is ln of r, or natural logarithm of r naught. I'm sorry, not r, r naught. And final expression will be k is equal to 2.303 divided by t log of square bracket r naught by square bracket r, and the t half for the first order reaction will be 0.693 by k. So when t becomes t half, you know that r naught becomes r naught by 2. By substituting these conditions, you can derive the half-life. Remember, half-life of first order reaction is independent of initial reactant concentration, is it not? R naught term illa formula dalli. So idanna prove ಮಾಡಲಿಕ್ಕೆ ಹೇಳ್ತಾರೆ. It's an important question. So the derivations out of 2, one derivation is a sure question. And also there may be problems on the k of first order and half life. ಇಲ್ಲಿ ನೆನಪಿಟ್ಕೊಳ್ಬೇಕಾದ ಅಂಶಗಳು ಏನಂದ್ರೆ ಒಂದು ವೇಳೆ ಪ್ರಾಬ್ಲಮ್ನಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅನ್ನು ಓಕೆ ರಿಯಾಕ್ಟೆಂಟ್ ಅಮೌಂಟ್ ಅನ್ನ ಪರ್ಸೆಂಟೇಜ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ ಆರ್ ನಾಟ್ ಆಸ್ 100. ಅದೇ ಫ್ರಾಕ್ಷನ್ ಅಲ್ಲಿ ರಿಯಾಕ್ಟೆಂಟ್ ಅಮೌಂಟ್ ಅನ್ನು ಕೊಟ್ಟರೆ ರಿಮೆಂಬರ್ ದ R naught value becomes 1, is it not? So these are the key points to solve the problem. And of course you know the unit, don't forget to write the unit. K unit is per time, it can be per second, per minute, and T half of course is second or minute, depending upon the values given in the problem. What are the other problems that can be asked from the unit? It is energy of activation. Let's just have a look at the formula, activation energy formula. It is log of K2 by K1 is equal to EA by 2.303 R into T2 minus T1 divided by T1 T2. Okay. If you write K2 by K1, remember it should be T2 minus T1, not T1 minus T2. And K1, K2 should be in the same system. The unit of K1 and K2 should be the same. Temperature must be in Kelvin. Okay, temperature cannot be substituted in degree Celsius, Kelvin nalle irbeku. Activation energy can be asked, ಅಥವಾ K1, K2 ಅಲ್ಲಿ ಯಾವ್ದಾದ್ರು ಒಂದು ಕೇಳ್ಬೋದು. Activation energy unit, you know, it is joule per mole. K1 and K2 units are per time, is it not? Then what are the other things to be taken care of in the problem? Of course, there is a log term, so you should know how to take log and anti-log. If the time permits, let us discuss it towards the end. So, based on this formula, there is almost a sure question, that is a numerical problem. Then other important topics are listed. Arrhenius equation and the terms can be asked. Graphs on temperature and catalyst influence on the rate can be asked. There may be questions on order, molecularity, their differences. Okay. Moving on to the last unit of physical chemistry. Yaudu? It is surface chemistry. 2 1 ಮಾರ್ಕಿನ ಕ್ವೆಶ್ಚನ್ ಮತ್ತೆ 1 5 ಮಾರ್ಕಿನ ಕ್ವೆಶ್ಚನ್ ಬರ್ತದೆ ಈ ಯೂನಿಟ್ ಇಂದ. ಶೋರ್ 100% ಶೋರ್ ಕ್ವೆಶ್ಚನ್ಸ್ ಅಂತ ಯಾವುದೂ ಇಲ್ಲ, ಬಟ್ ಅಪಿಯರ್ಡ್ ಕ್ವೆಶ್ಚನ್ಸ್ ಆ್ಯಂಡ್ ಪ್ರೊಬಾಬಲ್ ಕ್ವೆಶ್ಚನ್ಸ್ ಲಿಸ್ಟ್ ಔಟ್ ಮಾಡಿದ್ದೇನೆ. ಜಸ್ಟ್ ಹ್ಯಾವ್ ಅ ಲುಕ್ ಎಟ್ ದೆಮ್. ಡಿಫ್ರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದ ಟೈಪ್ಸ್ ಆಫ್ ಅಡ್ಸಾರ್ಪ್ಷನ್, ಫಿಸಿಸಾರ್ಪ್ಷನ್, ಕೆಮಿಸಾರ್ಪ್ಷನ್ ಕೇಳ್ಬೋದು. ದೆನ್ ಡೆಲ್ಟಾ ಎಚ್, ಡೆಲ್ಟಾ ಎಸ್ ಮತ್ತು ಡೆಲ್ಟಾ ಜಿಗಳ ಸೈನ್ಸ್ ಮೇಲೆ question irbodu. 2 types of catalysis and examples kelbodu. Kelavu terms, promoters, poisons, activity, selectivity of catalyst, and shape selective catalyst, that is geolites, is quite an important topic. Matte colloids na preparation, purification mele questions irbodu. Peptidization, Bradig's electric arc method idella. Also, lyophilic, lyophobic colloids na differences, and the 3 phenomena, Tyndall effect, Brownian motion, matte electrophoresis. So these are the most expected ones. And also Hardy-Skurl's rule statement matte small problems. Ondu sol kottu, ಕೆಲವೊಂದು electrolytes ಕೊಟ್ಟು ಅದರ coagulation order ಬರೀಲಿಕ್ಕೆ ಹೇಳ್ಬೋದು. Okay, so sure questions antilla, but probable questions are these. So with this, we have finished physical chemistry part of your syllabus. A part D, Roman number 4 nalli keluvantaddu. Now let's move on to the inorganic chemistry. Elli barutte idra questions? Section C elli barutte? 3 mark na questions ಆಗಿರುತ್ತೆ. First unit of inorganic chemistry, that is unit 6 of your textbook, general principles and processes of isolation of elements. One 1 mark question, one 2 mark question, matte one 3 mark question ide. Again, sure questions anta yaudu illa, but probable questions idella. Concentration in the 2 methods, froth flotation matte leaching of bauxite, idanna ಹೆಚ್ಚಾಗಿ ಕೇಳಿದ್ದಾರೆ ಹಿಂದಿನ ಕ್ವೆಶ್ಚನ್ ಪೇಪರ್ಸ್ ಅಲ್ಲಿ. ಲೀಚಿಂಗ್ ಆಫ್ ಬಾಕ್ಸೈಟ್ ನಲ್ಲಿ ಕೆಮಿಕಲ್ ಇಕ್ವೇಷನ್ಸ್ ಬರೀಲಿಕ್ಕಿದೆ, ನಿಮಗೆ ಗೊತ್ತು. ರಿಮೆಂಬರ್, ಇನ್ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿಯಲ್ಲಿ ಬರೀ ಇಕ್ವೇಷನ್ಸ್ ಅನ್ನ ಬರೆದ್ರೆ ಯು ವಿಲ್ ನಾಟ್ ಗೆಟ್ ಇವನ್ ಅ ಸಿಂಗಲ್ ಮಾರ್ಕ್. ಯು ಹ್ಯಾವ್ ಟು ಬ್ಯಾಲೆನ್ಸ್ ದ ಕೆಮಿಕಲ್ ಇಕ್ವೇಷನ್ಸ್ ವಿದೌಟ್ ಫೇಲ್. ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ, ಈವನ್ ಇಫ್ ಯು ಡೋಂಟ್ ಬ್ಯಾಲೆನ್ಸ್ ಇಟ್ ಇಸ್ ಓಕೆ, ಬಟ್ ಇನ್ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿಯಲ್ಲಿ ಬ್ಯಾಲೆನ್ಸ್ಡ್ ಕೆಮಿಕಲ್ ಇಕ್ವೇಷನ್ಸ್ ಆರ್ ಎಸೆನ್ಷಿಯಲ್. So you have to see to it that the balancing is learned properly. Leaching of bauxite ಅಲ್ಲಿ ನಿಮಗೆ ಬ್ಯಾಲೆನ್ಸಿಂಗ್ ಹೆಚ್ಚಿನ ತೊಂದರೆ ಕೊಡುವುದಿಲ್ಲ, ಯಾವುದೇ ಕೋಎಫಿಷಿಯಂಟ್ಸ್ ಅನ್ನು ನೀವು ಮೆಮರೈಸ್ ಮಾಡಬೇಕಾಗಿ ಬರುವುದಿಲ್ಲ. Then there may be questions on blast furnace ನ ಡಯಾಗ್ರಾಮ್ ಕೇಳ್ಬೋದು, ಅಥವಾ ಅಲ್ಲಿ ಬಳಕೆಯಾಗುವ ಬೇರೆ ಬೇರೆ ವಸ್ತುಗಳ ಮೇಲೆ ಅದರ ರೋಲ್ ಮೇಲೆ ಕ್ವೆಶ್ಚನ್ ಇರ್ಬೋದು. ಹೈ ಟೆಂಪರೇಚರ್, ಲೋ ಟೆಂಪರೇಚರ್ ರಿಯಾಕ್ಷನ್ಸ್ ಅನ್ನು ಬರೀರಿ ಅಂತ ಹೇಳ್ಬೋದು. One more important question is Hall-Héroult process of aluminium extraction. It's an electrolysis process, you know. ಅಲ್ಲಿ anode reaction, cathode reaction, CaF2 in a roll, Okay, such questions may come, or the entire process may be asked. Then purification nalli ee mooru methods, Mons process, nickel refining ige Van Arkel method, zirconium refining, okay, ಇದೆಲ್ಲದು important, zone refining ಕೂಡ important, but sure question anta illa. Coming to the largest unit of your syllabus, that is P block elements. ಇಲ್ಲಿ 1 mark and 2 mark questions ಇದೆಯಲ್ಲ, ಅದು ನೋಬಲ್ ಗ್ಯಾಸಸ್ಗೆ ಮೀಸಲಿಟ್ಟಿದ್ದಾರೆ. ಬೇರೆ ಗ್ರೂಪ್ಸ್ ಇಂದ ಬರೋದಿಲ್ಲ. ಗ್ರೂಪ್ 18 ಎಲಿಮೆಂಟ್ಸ್ ಇಂದ 1 mark and 2 mark ಕ್ವೆಶ್ಚನ್ಸ್ ಬರುತ್ತೆ. ಸೊ ಯಾವ ಟಾಪಿಕ್ಸ್ ಮೇಲೆ ಬರ್ಬೋದು? ಲುಕ್ ಎಟ್ ದ ಪಾಯಿಂಟ್ ನಂಬರ್ 6. ಪಾಯಿಂಟ್ ನಂಬರ್ 6 ನೋಡಿ, ನೋಬಲ್ ಗ್ಯಾಸ್ನ ಸೋರ್ಸ್ ಮೇಲೆ, ಅಥವಾ ಅದಕ್ಕೆ ಲೋ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಇದೆ, ಕಾರಣ ಕೊಡಿ. ಓಕೆ, ಇಂಥ ಕ್ವೆಶ್ಚನ್ಸ್ ಬರ್ಬೋದು. ಆ್ಯಂಡ್ ಆಲ್ಸೋ ಹೈಡ್ರಾಲಿಸಿಸ್ ಆಫ್ ನೋಬಲ್ ಗ್ಯಾಸ್ ಕಾಂಪೌಂಡ್ಸ್, ಅದರ ಮೇಲೆ ಕ್ವೆಶ್ಚನ್ಸ್ ಬಂದಿದೆ. ಶೋರ್ಟ್ ಕ್ವೆಶ್ಚನ್ ಅಂತ ಇಲ್ಲ ನೋಬಲ್ ಗ್ಯಾಸಲ್ಲಿ, 1 and 2 mark ಕ್ವೆಶ್ಚನ್ಸ್ ಮಾತ್ರ. ಬಟ್ 3 mark ಕ್ವೆಶ್ಚನ್ ಇದೆ ಅಲ್ಲ, ಗ್ರೂಪ್ 15, ಗ್ರೂಪ್ 16 ಆ್ಯಂಡ್ ಗ್ರೂಪ್ 17 ಇಂದ ಒಂದೊಂದು ಬರುತ್ತೆ. ಆ್ಯಂಡ್ ಇಲ್ಲಿ ಕೆಲವೊಂದು ಶಾರ್ಟ್ ಕ್ವೆಶ್ಚನ್ಸ್ ಇದೆ. ವಿಚ್ ಆರ್ ದೋಸ್? See, Haber's process, Oswald's process from group 15 and contact process from group 16. ಈ ಮೂರರಲ್ಲಿ ಒಂದನ್ನು ಕೇಳಿಯೇ ಕೇಳಬೇಕು ಅಂತ ಗೈಡ್ಲೈನ್ ಇದೆ. ಹೆಚ್ಚಾಗಿ ಫಸ್ಟ್ 2ರಲ್ಲಿ ಒಂದು ಕೇಳ್ತಾರೆ. ಓಕೆ, ಸೊ ಮ್ಯಾನ್ಯುಫ್ಯಾಕ್ಚರ್ ಆಫ್ ಅಮೋನಿಯಾ ಹೇಬರ್ಸ್ ಪ್ರಾಸೆಸ್ ಇಂದ, ಮ್ಯಾನ್ಯುಫ್ಯಾಕ್ಚರ್ ಆಫ್ ನೈಟ್ರಿಕ್ ಆಸಿಡ್ ಆಸ್ವಾಲ್ಡ್ಸ್ ಪ್ರಾಸೆಸ್ ಇಂದ, ಇದು 2ರಲ್ಲಿ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಗ್ರೂಪ್ 15ಅಲ್ಲಿ ಬಂದೇ ಬರುತ್ತೆ. ಓಕೆ, ಮ್ಯಾಕ್ಸಿಮಮ್ ಟೈಮ್ಸ್ ಇದು 2ರಲ್ಲೇ ಕೇಳ್ತಾರೆ. ಕಾಂಟ್ಯಾಕ್ಟ್ ಪ್ರಾಸೆಸ್ ಕೇಳುವ ಚಾನ್ಸಸ್ ಕಡಿಮೆ. ಅಗೇನ್ ಇಕ್ವೇಷನ್ಸ್ ಬರೆಯುವಾಗ ಸಿ ಟು ಇಟ್ ದಟ್ ದೇ ಆರ್ ಬ್ಯಾಲೆನ್ಸ್ಡ್. ಕಂಡೀಷನ್ಸ್ ಎಲ್ಲದೂ ಬರಿಬೇಕು. ರಿವರ್ಸಿಬಲ್ ರಿಯಾಕ್ಷನ್ ಇದ್ರೆ ಡೋಂಟ್ ಫಾರ್ಗೆಟ್ ಟು ರೈಟ್ ದ ರಿವರ್ಸಿಬಲ್ ಆರೋ. ಫಾರ್ ದ ಟಾಪ್ ಸ್ಕೋರರ್ಸ್ ದ ಮಾರ್ಕ್ ಮೇ ಬಿ ಡಿಡಕ್ಟೆಡ್ ಇಫ್ ಯು ಡೋಂಟ್ ರೈಟ್ ದ ರಿವರ್ಸಿಬಲ್ ಆರೋ. ಓಕೆ, ಸೊ ದೀಸ್ ಆರ್ ದ ಥಿಂಗ್ಸ್ ಟು ಬಿ ಟೇಕನ್ ಕೇರ್ ಆಫ್. ಆ್ಯಂಡ್ ಇಲ್ಲಿ ಕೆಲವೊಂದು ಕೀ ಪಾಯಿಂಟ್ಸ್ ಕೊಡಲಿಕ್ಕೆ ಇಷ್ಟಪಡ್ತೇನೆ. ಕೆಲವೊಂದು ರಿಯಾಕ್ಷನ್ಸ್ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಲಿಕ್ಕೆ ಒಂದು ಸ್ವಲ್ಪ ಕಷ್ಟ ಇದೆ. ಟ್ರಯಲ್ ಎರರ್ ಮೆಥಡಲ್ಲಿ ನೀವು ಮಾಡ್ತಾ ಕೂತ್ರೆ ಸ್ವಲ್ಪ ಟೈಮ್ ತಗೊಳ್ತದೆ. ಹಾಗಾಗಿ ಲೆಟ್ ಅಸ್ ಸಿ ಹೌ ಟು ರಿಮೆಂಬರ್ ದ ಕೋಎಫಿಷಿಯಂಟ್ಸ್. ಬ್ಯಾಲೆನ್ಸಿಂಗ್ ಮಾಡುವಾಗ ಹೇಗೆ ನೆನ್ಪಿಟ್ಕೊಳ್ಬೋದು ಅಂತ ಒಂದು ಸ್ವಲ್ಪ ನೋಡುವ. ಆಸ್ವಾಲ್ಡ್ಸ್ ಪ್ರಾಸೆಸ್ಸಲ್ಲಿ ಯು ಹ್ಯಾವ್ ಅ ವೆರಿ ಫಸ್ಟ್ ಸ್ಟೆಪ್, ದಟ್ ಇಸ್ ಅಮೋನಿಯಾ ಆಕ್ಸಿಡೈಸ್ ಆಗಿ ನೈಟ್ರೋಜನಿನ ಮೊನಾಕ್ಸೈಡ್ ಮತ್ತು ವಾಟರ್ ಕೊಡುವ ರಿಯಾಕ್ಷನ್, ಇಸ್ ಇಟ್ ನಾಟ್? ಇಲ್ಲಿ ವಿ ರಿಮೆಂಬರ್ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ರಿಯಾಕ್ಷನ್ ಬ್ಯಾಲೆನ್ಸಿಂಗ್ ಲೈಕ್ ದಿಸ್. ವಿ ಕಾಲ್ ದಿಸ್ ರಿಯಾಕ್ಷನ್ 45 and 46 ರಿಯಾಕ್ಷನ್. ಓಕೆ, ಈ ಥರ ನೆನ್ಪಿಟ್ಕೊಳ್ತೇವೆ. ಕೋಎಫಿಷಿಯನ್ಸನ್ನು ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡ್ತಾ ಕೂರಬೇಕಾಗಿಲ್ಲ. ಯು ಕ್ಯಾನ್ ರಿಮೆಂಬರ್ 45, 46 ಈ 2 ನಂಬರ್ಸ್ ನೆನ್ಪಿಟ್ಕೊಳ್ಬೋದು. ದಟ್ ವಿಲ್ ಸೇವ್ ಯೋರ್ ಟೈಮ್. ಆ್ಯಂಡ್ ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್ ಇದೆ ಅಲ್ಲ, ಇದೇ ರಿಯಾಕ್ಷನಲ್ಲಿ ಅಫ್ಕೋರ್ಸ್ ಫಸ್ಟ್ ಸ್ಟೆಪ್ಪಿಗೆ ಯು ಹ್ಯಾವ್ ಟು ಗಿವ್ ಆಲ್ ದ ಕಂಡೀಷನ್ಸ್: ಪ್ಲಾಟಿನಮ್, ರೋಡಿಯಂ ಗಾಸ್, ದ ಕ್ಯಾಟಲಿಸ್ಟ್, ಆ್ಯಂಡ್ 500 Kelvin ಟೆಂಪರೇಚರ್, 9 bar ಪ್ರೆಷರ್. ಇಟ್ ಈಸ್ ವೆರಿ ಎಸೆನ್ಷಿಯಲ್. ಅದು ಬರೆಯದೇ ಇದ್ದರೆ ಮಾರ್ಕ್ಸ್ ಸಿಗೋದಿಲ್ಲ. ಆ್ಯಂಡ್ ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್ಪಲ್ಲಿ ದಟ್ ಈಸ್ NO ಪ್ಲಸ್ O2 ಗಿವಿಂಗ್ NO2. ಇದರಲ್ಲಿ ರಿವರ್ಸಿಬಲ್ ಆರೋ ಬೇಕು. ಫಿಸಿಕಲ್ ಸ್ಟೇಟ್ಸ್ ಮೆನ್ಷನ್ ಮಾಡಿ ಎಲ್ಲದರದ್ದು ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಿದರೆ ಇಟ್ ವಿಲ್ ಬಿ 2NO ಹಿಯರ್ ಆ್ಯಂಡ್ 2NO2 ಹಿಯರ್. ಇಸ್ ಇಟ್ ನಾಟ್? ಡೋಂಟ್ ಫಾರ್ಗೆಟ್ ಟು ರೈಟ್ ದ ರಿವರ್ಸಿಬಲ್ ಆರೋ. Okay, there is nothing special in the last step. So 45, 46 reaction, 1 point, and the reversible arrow in the second step. Okay, that is the second key point. Haber's process allu hage reversible arrow matte conditions mention ಮಾಡೋದನ್ನ ಮರಿಬೇಡಿ. Then which are the other important topics from the P block elements? See, since the manufacture is asked from group 15 in the manufacture question ಬರುವ ಕಾರಣ ಬೇರೆ ಕ್ವೆಶ್ಚನ್ಸ್ ಅನ್ನ ನೀವು 16 ಮತ್ತು 17 ಇಂದ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ಬೋದು. ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಪ್ರತಿ ಗ್ರೂಪ್ ಇದ್ದು ಸ್ವಲ್ಪ ಅಬ್ನಾರ್ಮಲ್ ಆಗಿ ಬಿಹೇವ್ ಮಾಡುತ್ತಲ್ವಾ, ಸೊ ಅದರ ಮೇಲೆ ಅನಾಮಲಸ್ ಪ್ರಾಪರ್ಟೀಸ್ ಕೇಳ್ತಾರೆ. Anomalous properties of nitrogen, oxygen and fluorine. You can expect from 16 and 17, that is anomalous properties of oxygen, fluorine anna keluva chances ide. Then structures of oxo acids, one more important question. Okay, chlorine in oxo acids, phosphorus, sulfur in oxo acids. Hechagi sulfur, chlorine and sulfur. Okay, most of the times it is oxo acid of chlorine that is our structure keltare, and a set of reactions will be given to you and you will be asked to complete the reactions. Neevu old question papers inda ella equations reactions anna ottu maadi neevagi reactions anna complete madlikke kalibeku. Okay, so complete the equations for the reactions, intaha questions kuda irbodu. And interhalogens mele questions, adara reactivity mele barbodu. So these are the probable questions from P block elements. The next inorganic chemistry unit is D and F block elements. 1 markina 1 question ide matte 3 markina 3 questions ide. So the weightage given is quite high. Here there is a 100% sure question, which is that it is preparation of potassium dichromate or preparation of potassium permanganate. See, balanced chemical equations are must here. Sometimes explanation is not asked, only the equations are asked. Potassium dichromate na manufacture nalli first step, okay, that will give you some problem during balancing. Alli coefficients anna ನೆನಪಿಟ್ಕೊಳ್ಳೋದು ಒಳ್ಳೆಯದು. What is that first step? How do you prepare potassium dichromate? It is prepared from chrome iron ore, is it not? The formula of chrome iron ore is FeCr2O4. Okay, so this chrome iron ore is fused with sodium carbonate in the presence of oxygen, and you get sodium chromate, a yellow colored compound, and as a byproduct you also get Fe2O3 and CO2. So here what we do is we remember the coefficients as 4, 8 and 7 on left hand side. Okay, otherwise balancing takes time. 487 we remember. Of course the reactants should be written in the same order alli reactants anna baribeku. You can remember 487 and adanna nodikondu right hand side anna easily balance ಮಾಡಬಹುದು. So idu ಒಂದು ಸ್ಟೆಪ್ ಇದೆ ಅಲ್ಲ, ಅದು ಸ್ವಲ್ಪ ಕಷ್ಟ ಇದರಲ್ಲಿ ಬರೀಲಿಕ್ಕೆ. ಇದನ್ನ ಬರೆದ್ರೆ then second and third steps are not that difficult. Okay, so similarly permanganate manufacturing, it has got 2 steps. ಎರಡು ಸ್ಟೆಪ್ಪಿಗೆ ಬ್ಯಾಲೆನ್ಸ್ ಇಕ್ವೇಷನ್ಸ್ ಬೇಕು. ಡೋಂಟ್ ಫಾರ್ಗೆಟ್ ಟು ಬ್ಯಾಲೆನ್ಸ್ ದೆಮ್. ಅಲ್ಲಿ ಬ್ಯಾಲೆನ್ಸಿಂಗ್ ಅಷ್ಟೇನು ಸಮಸ್ಯೆ ಕೊಡೋದಿಲ್ಲ. ಮ್ಯಾನ್ಯುಫ್ಯಾಕ್ಚರ್ ಬಿಟ್ಟು ಬೇರೆ ಯಾವ ಕ್ವೆಶ್ಚನ್ಸ್ ಬರುತ್ತೆ ಡಿ ಆ್ಯಂಡ್ ಎಫ್ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಇಂದ? ದೆರ್ ಆರ್ ಸರ್ಟನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ರಾಪರ್ಟೀಸ್, catalytic properties of D block elements, complex formation, interstitial compound formation, and color and magnetic properties. ಯಾವುದಕ್ಕೆ ಕಲರ್ ಇದೆ, ಯಾವುದಕ್ಕೆ ಇಲ್ಲ. ಡಿ ಟ್ರಾನ್ಸಿಷನ್ ಇದ್ದರೆ ಕಲರ್ ಇರುತ್ತೆ ಅಲ್ವಾ, D0 ಮತ್ತು D10 ಕಾನ್ಫಿಗರೇಷನ್ ಬಿಟ್ಟು ಬಾಕಿದ್ದು ಎಲ್ಲದಕ್ಕೂ ಡಿ ಟ್ರಾನ್ಸಿಷನ್ ಸಾಧ್ಯ ಇದೆ. ದ್ಯಾಟ್ ಇಸ್ ವೈ ಕಲರ್ ಇರುತ್ತೆ. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟಿ, ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ದರೆ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್, ಅದರ್ವೈಸ್ ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್. ಸೊ ಅದರ ಮೇಲೆ ಕ್ವೆಶ್ಚನ್ಸ್ ಬರುತ್ತೆ. ಯಾಕೆ ಡಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ಗುಡ್ ಕ್ಯಾಟಲಿಸ್ಟ್? Because they have variable oxidation states, is it not? One of the reasons. And they form complexes, correct? That is the other reason. Complex formation ability yaudrindagi bandide? Adara small size, high charge indagi, and also adaralli bonding ige d orbitals bekadashtu available irodrinda. Hage interstitial compound formation, idu ಕೆಲವೊಂದು important topics, important properties. See, 3 mark question ನಲ್ಲಿ ಮೂರನೇ question F block elements ಗೆ ಮೀಸಲಿಟ್ಟಿದ್ದಾರೆ. ಅದರಲ್ಲಿ 100% sure ಅಲ್ಲ, but expected question ಯಾವುದು ಅಂದರೆ lanthanoid contraction. Lanthanoids ಅಲ್ಲಿ atomic number ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋದ ಹಾಗೆ size gradually decrease ಕಾಣ್ತದೆ. Imperfect shielding of 4f electrons ಇಂದಾಗಿ, is it not? So that is lanthanoid contraction. ಅದರ cause ಕೇಳ್ಬೋದು. Consequence ಏನು? 4D and corresponding 5D elements ಗೆ same size ಇದೆ, is it not? So consequences of lanthanoid contraction ಕೇಳ್ಬೋದು, cause ಕೇಳ್ಬೋದು, definition ಕೇಳ್ಬೋದು. Then lanthanoid ಮತ್ತು actinoids ಅನ್ನ ಕಂಪೇರ್ ಮಾಡಿ ಕಂಪ್ಯಾರಿಟಿವ್ ಸ್ಟಡಿ ಮೇಲೆ ಕ್ವೆಶ್ಚನ್ಸ್ ಬರ್ಬೋದು. ಓಕೆ, ಡಿಫ್ರೆನ್ಸಸ್ ಕೇಳ್ಬೋದು. ಲ್ಯಾಂಥನಾಯ್ಡ್ಸ್ಗೆ ರೇಡಿಯೋ ಆಕ್ಟಿವಿಟಿ ನೇಚರ್ ಇಲ್ಲ, ಆಕ್ಟಿನಾಯ್ಡ್ಸ್ಗೆ ಇದೆ. ಲ್ಯಾಂಥನಾಯ್ಡ್ಸ್ನ ರಿಯಾಕ್ಟಿವಿಟಿ ಕಡಿಮೆ, ಆಕ್ಟಿನಾಯ್ಡ್ಸ್ ಇದ್ದು ಜಾಸ್ತಿ. ಓಕೆ, such are the key points here. Coming to the next inorganic unit, that is coordination compounds. ಇಲ್ಲಿ 1-2 ಮಾರ್ಕ್ನ ಯಾವುದೇ ಕ್ವೆಶ್ಚನ್ಸ್ ಇಲ್ಲ, ಬಟ್ 3 ಮಾರ್ಕಿನ 3 ಕ್ವೆಶ್ಚನ್ಸ್ ಇದೆ. ಇಲ್ಲಿ ಒಂದು 100% ಶೋರ್ ಕ್ವೆಶ್ಚನ್ ಇದೆ. 4 ಕಾಂಪ್ಲೆಕ್ಸಸ್, ಓಕೆ, ವಿಚ್ ಆರ್ ಲಿಸ್ಟೆಡ್ ಆನ್ ದ ಸ್ಕ್ರೀನ್. ಆ 4 ಕಾಂಪ್ಲೆಕ್ಸಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ನ ಮೇಲೆ ಕ್ವೆಶ್ಚನ್ ಬರುತ್ತೆ. ಫೀಚರ್ಸ್, ಅದರ ಹೈಬ್ರಿಡೈಸೇಷನ್, ಕಾಂಪ್ಲೆಕ್ಸಿನ ಟೈಪ್, ಅದರ ಶೇಪ್, ಅದರ ಮ್ಯಾಗ್ನೆಟಿಕ್ ನೇಚರ್, ಓಕೆ, ಅದರ ಮೇಲೆ ಕ್ವೆಶ್ಚನ್ ಬಂದೇ ಬರುತ್ತೆ 4ರಲ್ಲಿ 1. ಸೊ ದಿಸ್ ಈಸ್ ಅ 100% ಶೋರ್ ಕ್ವೆಶ್ಚನ್. So let us see the solution for the features of the complexes. See, when you answer this question, remember one thing, it is not enough if you just specify the features. Hybridization ಯಾವುದು, ಅದು ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ, ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ, ಶೇಪ್ ಯಾವುದು ಅಂತ ಅಷ್ಟೇ ಸ್ಪೆಸಿಫೈ ಮಾಡಿದರೆ ಸಾಲುವುದಿಲ್ಲ. You have to go systematically. For example, I'll take the very first complex. It is CO, it's a cobalt complex, CONH3 6 times 3 plus. Okay, so ಈ ಕಾಂಪ್ಲೆಕ್ಸ್ ಅಲ್ಲಿ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಅಯಾನ್ ಆಗಿ CO3 ಪ್ಲಸ್ ಇದೆ. ಕೋಬಾಲ್ಟಿನ ಅಟಾಮಿಕ್ ನಂಬರ್ ಇಸ್ 27. ಸೊ ಕಾನ್ಫಿಗರೇಷನ್, ಔಟರ್ ಕಾನ್ಫಿಗರೇಷನ್ ಕಮ್ಸ್ ಔಟ್ ಟು ಬಿ 3d7 4s2. ಬಾಕ್ಸ್ ಡಯಾಗ್ರಾಮ್ ಬರೆದು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಬೇಕು ಕಾನ್ಫಿಗರೇಷನ್ ಅನ್ನ. ಐ ಆಮ್ ಜಸ್ಟ್ ಗಿವಿಂಗ್ ಯು ದ ಹಿಂಟ್ಸ್. ಸೊ CO3 ಪ್ಲಸ್ ಏನಾಗುತ್ತೆ, ಇಟ್ ಬಿಕಮ್ಸ್ 3d6. ಅಗೇನ್ ಯು ರೈಟ್ ದ ಬಾಕ್ಸ್ ಡಯಾಗ್ರಾಮ್. ಈಗ ಅಮೀನ್ ಲಿಗ್ಯಾಂಡ್ಸ್ ಇದೆ ಅಲ್ಲ, ಅದು ಏನು ಮಾಡುತ್ತೆ, ನಿಮ್ಮ CO3 ಪ್ಲಸ್ ನಲ್ಲಿ, CO3 ಪ್ಲಸ್ ದ ಕೊಬಾಲ್ಟ್ 3 ಪ್ಲಸ್ ಅಯಾನ್ನಲ್ಲಿ ಇಲೆಕ್ಟ್ರಾನ್ನ ಪೇರಿಂಗನ್ನು ಇಂಡ್ಯೂಸ್ ಮಾಡ್ತದೆ. ಹಾಗಾಗಿ the hybridization becomes D2sp3, is it not? Electron pairing anna ತೋರಿಸಬೇಕು ಬಾಕ್ಸ್ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ, and hybridization as a result becomes D2sp3. so shape, resultant shape becomes octahedral, and paired electrons ಇರುವ ಕಾರಣ there will not be any magnetic property. Okay, magnetic property of the complex will be diamagnetic. So don't just write the features, you give a clear background, box diagrams haki, configurations haki, hybridizations alla mark ಮಾಡಿ. Because the hybridization is D2sp3, you say it is octahedral, and because there are no unpaired electrons, you say it is diamagnetic. And of course, ಒಳಗಿನ D, that is 3D hybridization ಅಲ್ಲಿ ಇನ್ವಾಲ್ವ್ ಆಗಿರುತ್ತಲ್ವ ಇಲ್ಲಿ, ಹಾಗಾಗಿ it is an inner complex, type of complex, inner complex. ಸೊ ಇಷ್ಟು ಫೀಚರ್ಸ್ ಅನ್ನ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಬೇಕು ಪ್ರತಿ ಕಾಂಪ್ಲೆಕ್ಸ್ನಲ್ಲಿ ಕೂಡ. ಕಾಂಪ್ಲೆಕ್ಸಸ್ ಬಿಟ್ಟರೆ ವರ್ನಸ್ ಥಿಯರಿಯ ಪಾಸ್ಟುಲೇಟ್ಸ್ ಕೇಳ್ಬೋದು. 3 ಕ್ವೆಶ್ಚನ್ಸ್ ಇದೆ ಅಲ್ವಾ, ಹಾಗಾಗಿ ವರ್ನಸ್ ಥಿಯರಿ ಪಾಸ್ಟುಲೇಟ್ಸ್ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ಬೋದು. ಐಸೋಮೆರಿಸಮ್, ಬೋತ್ ಸ್ಟ್ರಕ್ಚರಲ್ ಆ್ಯಂಡ್ ಸ್ಟೀರಿಯೋ, ಆಯಿತಾ. ಯಾವುದೇ ಒಂದು ಐಸೋಮೆರಿಸಮ್ ಹೇಳಿ ಅದರ ಎಕ್ಸಾಂಪಲ್ ಕೇಳ್ಬೋದು. ಸ್ಟೀರಿಯೋ ಐಸೋಮರ್ಸ್ ಬರೀಲಿಕ್ಕೆ, ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಬರೀಲಿಕ್ಕೆ, ಸಿಸ್ ಆ್ಯಂಡ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ಸ್ ಬರೀಲಿಕ್ಕೆ ಹೇಳ್ಬೋದು ಫಾರ್ಮುಲಾ ಕೊಟ್ಟು. ಸೊ ಸಚ್ ಕ್ವೆಶ್ಚನ್ಸ್. ಆ್ಯಂಡ್ questions on the IUPAC names and formula of the complexes may come. These are just the probable ones. Okay, so with that we have finished the inorganic chemistry portions of your textbook. Now moving on to the last and the vast section, that is part D, Roman number 5, organic chemistry. The first unit here is haloalkanes and haloarenes. Weightage is 1 plus 2 plus 5. Here there is a sure question. See, actually in organic chemistry we have got 4 mechanisms, out of which the guidelines say one must be asked and the other may be asked. A 4 mechanisms yaudu? SN1, SN2 ಈ ಯೂನಿಟ್ ಇಂದ. ಮತ್ತೆ next unit alcohol, phenols, ethers ಇಂದ dehydration of ethanol to ethene. ಅದರ next unit carbonyl compounds ಇಂದ addition of HCN to carbonyl compounds. ಈ 4 mechanisms ಅಲ್ಲಿ ಒಂದು ಬಂದೇ ಬರುತ್ತೆ and ಇನ್ನೊಂದು ಕೂಡ ಕೇಳಬಹುದು ಅಂತ ಗೈಡ್ಲೈನ್ಸ್ ಅಲ್ಲಿ ಇದೆ. ಹಾಗಾಗಿ SN1 and SN2 mechanisms ಅಲ್ಲಿ we expect one mechanism to be asked. SN1, what is that 1? 1 is the order, but remember the steps are 2. ಇಲ್ಲಿ bulky alkyl halide ಅನ್ನು ನೀವು ತಗೊಳ್ತೀರಿ, tertiary butyl bromide example. Okay, ಹಾಗಾಗಿ first step ಅಲ್ಲಿ it undergoes splitting or decomposition and it forms a tertiary carbocation. Remember, that is the slow step and reversible arrow ಬರಿಬೇಕು step 1 ಗೆ. mechanism ನಲ್ಲಿ arrows ತೋರಿಸಬೇಕು. Okay, charges ಅನ್ನ clear cut ಆಗಿ ಬರಿಬೇಕು, otherwise you will lose the marks. So after that first step, which is a slow step, which is a reversible step, second step ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, carbocation nucleophile ಇಂದ attack ಗೆ ಒಳಪಟ್ಟು final product tertiary butyl alcohol formation ಮಾಡ್ತದೆ. So the 2 steps should be clearly shown with all the arrows, the charges. Okay, SN2 ಅಲ್ಲಿ 2 stands for the order. Order is 2 there, but step is only 1. Here you take simple halides like methyl chloride. Okay, ಒಂದೇ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಅದು ರಿಯಾಕ್ಷನ್ ಗೆ ಒಳಪಡ್ತದೆ. ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ OH- ಅದನ್ನ ಬ್ಯಾಕ್ ಸೈಡ್ ಇಂದ ಅಟ್ಯಾಕ್ ಮಾಡ್ತದೆ ಅಲ್ವಾ. CCl ಬಾಂಡ್ ಇನ ಬ್ಯಾಕ್ ಸೈಡ್ ಇಂದ ಅಟ್ಯಾಕ್ ಮಾಡುತ್ತೆ, ಒಂದು ಅನ್ಸ್ಟೇಬಲ್ ಟ್ರಾನ್ಸಿಷನ್ ಸ್ಟೇಟ್ ಸಿಗ್ತದೆ. And that transition state slowly changes, not slowly, it changes into product. So in a single step the reaction takes place. Okay, order is 2 but the step is only 1. So out of these 2 mechanisms, one is a sure question. And in organic chemistry there are a number of named reactions named after the various chemists. Okay, so out of those named reactions, I have listed the named reactions from each and every unit. You can see them. So out of those named reactions, remember minimum 8 mark questions. That is 4 reactions are compulsory. They are asked. Okay, and out of those 4, 2 are asked directly. For example, what is Schwarz reaction? Give an example. Okay, directly they'll be asked, and 2 more can be asked indirectly. So this is the guideline. ಹಾಗಾಗಿ ನೇಮ್ಡ್ ರಿಯಾಕ್ಷನ್ಸ್ ಅನ್ನ ಪ್ರತಿ ಯೂನಿಟ್ ಇಂದ ಲಿಸ್ಟ್ ಮಾಡಿದ್ದೇನೆ. ಆ ಲಿಸ್ಟ್ ಅನ್ನ ತಗೊಂಡು ಅದಕ್ಕೆ ಅನುಗುಣವಾಗಿ ಎಲ್ಲವನ್ನ ಓದಿಕೊಂಡ್ರೆ surely you will get 8 marks. Okay, but this time it can even be more since the number of questions are more. Okay, chances of asking the named reactions is also more. Fine. So named reactions here are Schwarz, Finkelstein. See, Finkelstein starts with the F, but remember it is for iodo compound preparation, not for fluoro compound. Okay, Schwarz is for fluoro compound. Okay, Wood's reaction is a topic of first year. It may not be asked here, but Wood's Fittig reaction and Fittig reaction are the named reactions. And there are other reactions also, dehydrohalogenation or beta elimination. They can also be asked. The next unit from organic chemistry is alcohols, phenols and ethers. As you can see, there is one mark question and 2 5-mark questions, totally 11 mark. Here there is a sure question, that is mechanism of dehydration of ethanol to ethene. Out of 4 mechanisms, I have already told you, one is a must and the other may be asked. So, this mechanism has got 3 steps. First step is protonation of ethanol. The second is loss of water molecule to form a ethyl carbocation. And in the third step, elimination of proton takes place to form the alkene ethene. You have to give the equations for all the 3 steps with the arrow marks and the charges wherever they are required. Then there are named reactions in the unit as well. The named reactions are cumene process, coal-base reaction, cumene process to synthesize phenol, coal-base reaction to convert phenol to salicylic acid, Riemann-Tiemann reaction for salicylaldehyde preparation, and Williamson's ether synthesis. All the named reactions you have to study. There are other important reactions as well. Esterification, dehydrogenation reaction using hot copper, Grignard reaction. Actually, in the organic syllabus, you find 4 Grignard reactions which can be taken as important ones. Which are they? See, if you subject formaldehyde to Grignard addition followed by hydrolysis, then you get primary alcohol. Any other aldehyde in the same method will give you secondary alcohol, and ketone if you take and do Grignard addition and hydrolysis, you get tertiary alcohol. Instead of taking carbonyl compounds, if you take nitrile and do the Grignard addition and hydrolysis process, then you get a ketone. Also, if you take carbon dioxide, okay, and you do Grignard addition and hydrolysis, you get a carboxylic acid. So, all these Grignard reactions must be studied. You can expect at least one from these. Then reaction of phenol with zinc dust to give benzene, reaction of ethers with HX or HI, okay, these are expected questions. Then there is acidity concept in this unit, not only in this unit, even in the next unit. What is the order of acidic strength? Actually, alcohols are least acidic, then come phenols, and carboxylic acids are the most acidic ones. The reason is, after the loss of proton, alcohols form alkoxide ion which is not resonance stabilized. But in the case of phenol, phenoxide ion is formed. This is resonance stabilized. In the case of carboxylic acid, carboxylate anion is formed. This is not only resonance stabilized, but it has got equivalent resonance structures. So, the acidity order is alcohols, least acidic, then phenols, then carboxylic acids. So, acidity is an important topic. See, electron releasing groups, if they are present on these compounds, they decrease the acidity because the corresponding ion, in the case of phenol, the phenoxide ion gets destabilized by electron releasing groups. On the other hand, if electron withdrawing groups are present, what happens is the corresponding ion, in the case of phenol, the phenoxide ion, it gets stabilized. The stability of the corresponding ion becomes more, and so the corresponding compound becomes more acidic. Okay, so this is the influence of groups on acidity. Even these concepts may be asked. Coming to the next topic, next unit, that is carbonyl compounds. In this unit, you have one 1-mark question and 2 5-mark questions. There is an important mechanism, that is HCN addition to carbonyl compound. Actually, the medium required here is a base. HCN first reacts with OH minus. It gives you a CN minus, the nucleophile. That nucleophile adds to carbonyl compound. It forms a tetrahedral intermediate, which later takes up a proton from the medium, forming cyanohydrin. So, equations for the steps have to be clearly shown. The named reactions from this unit are Rosen-Mundt reaction or reduction, conversion of benzoyl chloride to benzaldehyde takes place here. Then Stephens reaction, Itard reaction, here we convert toluene to benzaldehyde. There is Gattermann-Koch reaction, Friedel-Crafts acylation. Actually, Friedel-Crafts acylation is a part of electrophilic or aromatic substitution reaction. See, aromatic substitutions come in almost all the units of organic chemistry. So, what you can do is you can prepare a chart collecting all those aromatic reactions and you can compare and study them. So, let us briefly summarize those electrophilic substitution reactions. If you see chlorobenzene and also phenol and anisole, remember you get ortho and para products in the electrophilic substitution. Whereas, if you see benzaldehyde, benzoic acid, they will give you meta products. So, collect all the electrophilic substitutions, classify them as ortho-para directing group containing compounds and meta directing group containing compounds, and you can have a comparative study. Then there are other named reactions like Clemmensen reduction. Here we convert carbonyl group to hydrocarbon. CO group is converted to CH2 group. Same thing is done in Wolff-Kishner reduction also, but the route or the reagent used is different. Cannizzaro reaction for carbonyl compounds having no alpha hydrogen. H-Weiser reaction for carboxylic acid containing alpha hydrogen. So, all these reactions are quite important. The other important ones are haloform reaction, aldol reaction, and you also have aldol condensation, cross aldol condensation, and the decarboxylation in carboxylic acids. These are also the important topics to be studied. The next unit is amines. From this unit, you will get a 2-mark question and a 5-mark question. There are no sure questions, but of course there are named reactions. Yadella named reactions are Gabriel thalamide synthesis, Hoffman bromamide reaction from the preparation, then reactions in the carbyl amine reaction, Gattermann reaction, and of course you have Sand-Meyer reaction. Okay. So, these are the important named reactions. Then there are other reactions as well. Diazonium salts in the diazotization. Mooru type na amines anna differentiate ಮಾಡಲಿಕ್ಕೆ Hinsberg test ಇದೆ. And the next important topic is basicity of amines. Just like the acidity in the case of alcohols, phenols and carboxylic acids. In the case of amines, you have the basic strengths. What you need to remember here is basic strength increases if at all electron releasing groups are present, because electron releasing groups increase the availability of electrons on nitrogen atom. So the basic strength of amines increases. If electron withdrawing groups are present, then electron density on nitrogen decreases and the basic strength also decreases. If you have ammonia and aniline, which is more basic, I'm sorry, if you have amines, aliphatic amines, ammonia and then aniline, which is more basic, aliphatic amines are more basic, then comes our ammonia and finally aniline. What is the reason? In the case of aliphatic amines, you have electron releasing groups, okay, because of their plus I effect, electron availability on nitrogen increases. In the case of ammonia, you do not have any such groups, but in the case of aniline, the nitrogen lone pair electrons are involved in some other work, that is, they are busy in resonance. They are not available for donation and hence aniline becomes less basic. So, basic strength, order and even the reason behind it is a probable question. Okay, so that was about your amines. The next unit is biomolecules. You only have 2 5-mark questions from this unit, and almost a sure question is Haworth structures of disaccharides. Which are the disaccharides? That we have sucrose, maltose and lactose. So, their Haworth structures are important. Let us see the Haworth structure of say alpha D maltose. You know very well that maltose is made up of 2 glucose unit, is it not? Both the glucose units are in the alpha form. How to write their Haworth structure? You have to write a 6-membered ring, 1 atom being oxygen and each and every carbon should be given 2 groups. Okay, so carbon number 1 has H, OH. Carbon number 2 has HOH. See to it that you fill all the hydrogens and oxygens without fail in the exam. Even if you miss 1 atom or group, you will lose 2 marks. This question is for 2 marks. Okay, third carbon you know very well, it is OHH. Is it not? And the 4th carbon is again HOH. 5th carbon has CH2OH and H. I have to write one more such glucose unit. So, a similar glucose unit must be written bearing the groups at the same positions. So, here there is HOH, HOH again, 3rd carbon is OHH, 4th being HOH and the 5th is CH2OH and H. Okay. Now, between the two glucose units, there is a C1C4 glycosidic link, right? In order to form a maltose, you have to make this link by removing a water molecule. This is my C1 and this is my C4. So, I will remove a water molecule and form a glycosidic linkage. So, then you get maltose. Okay. So, this is how you can write the structure of maltose. Similarly, sucrose and lactose structures can also be studied. So, one out of the three structures is a almost sure question. Okay. Then reducing and non-reducing sugars, what are they and the examples can be asked. You do not find many non-reducing sugars. Sucrose is one typical example. Then from structural elucidation, reactions ಕೇಳ್ಬೋದು. ಗ್ಲೂಕೋಸ್ನಲ್ಲಿ ಎಲ್ಲ 6 ಕಾರ್ಬನ್ ಸ್ಟ್ರೇಟ್ ಚೈನಲ್ಲಿ ಇದೆ ಅಂತ ಪ್ರೂವ್ ಮಾಡಿ. Okay, they may ask you such questions. Then from types of amino acids, essential and non-essential. Okay, there may be questions. Remember, lysine is essential. Questions on peptide bond in tetrapeptide. How many peptide bonds are present? The answer is 3. Denaturation of proteins, vitamin ಮತ್ತೆ ಅದರ deficiency disease ಮೇಲೆ question. DNA and RNA components ಮೇಲೆ question ಇರುತ್ತೆ. See, which are the nitrogen bases present in DNA? They are adenine, guanine, cytosine and thymine. Whereas in RNA, adenine, guanine, cytosine and you have uracil. Okay, so such questions will come from biomolecules. The next topic is polymers. There are no sure questions. Different types of polymers and their monomers is an expected question. Of course, examples for biodegradable polymers, PH, BB, and nylon 2, nylon 6. Okay, that is also important. Now, what you can do here is you can prepare a table of polymer and the monomers, and you can list all the examples from the slide and you can study it. Natural rubber is an important one, and even nylon 6,6 has been asked many a times. Okay, so the last unit from organic chemistry is chemistry in everyday life. I've told you in the beginning there are no 5-mark questions here. You have 2-mark questions, 2 in number, and of course there is a 1-mark question. See, this particular unit can be divided into 2 halves. One is the medicines or drugs, okay, and the other one is chemicals used in food and chemicals used as cleaning agents. So, out of 2-mark questions, most probably one is going to come from drugs and the other from the chemicals other than drugs. So, what you need to do is you have to learn the definition of each and every class of drug. That is, what is it? What is an antacid? What is an antibiotic? And you have to study at least 1 example for each class. And it is better to have the knowledge of all other examples, because if they give you 1 example, okay, ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟು ಅದು ಯಾವ ಕ್ಲಾಸಿನ ಡ್ರಗ್ ಅಂತ ಕೇಳುವ ಚಾನ್ಸ್ ಇರುತ್ತೆ. ಅದಕ್ಕೆ ಎಲ್ಲ ಎಕ್ಸಾಂಪಲ್ನ ನಾಲೆಜ್ ಇರಬೇಕು, ಸ್ವಲ್ಪ ಆದರೂ ಫ್ಯಾಮಿಲಿಯರ್ ಇರಬೇಕು. ಬಟ್ ಒಂದು ಎಕ್ಸಾಂಪಲನ್ನು ಕರೆಕ್ಟಾಗಿ ಸ್ಪೆಲ್ಲಿಂಗ್ ಸಮೇತ ಸರಿಯಾಗಿ ನೋಡ್ಕೊಳ್ಬೇಕು. ಓಕೆ, ವೆನ್ ದೇ ಆಸ್ಕ್ ನೇಮ್ an antibiotic, you have to write penicillin with the correct spelling. Even the spelling mistakes there may prove risky. Okay, you may lose your marks. All right, so that is about all the important questions. Now, let us take up the question paper published by the Department of Pre-University Education, Karnataka, the model question paper, and let us try to have the solutions, a brief note on their solutions, especially the 1 mark and 2 mark questions. Let us solve. Okay, so if you see the model paper, the very first question from solids is what are F centers? They are nothing but anionic sites occupied by unpaired electrons in the crystal. Then the second question is from solutions. How does the enthalpy change on mixing two volatile liquids to form ideal solution? Because it's an ideal solution, the enthalpy change is 0, or enthalpy does not change. Third question is also from solutions. Give an example for natural semi-permeable membrane. It can be pig's bladder or parchment can also be given. Fourth one is from electrochemistry. What happens to molar conductivity when 1 mole of potassium chloride dissolved in 1 liter is diluted to 5 liters? You know that on dilution, molar conductivity increases, is it not? If you dilute the solution, molar conductivity increases. So the answer is, it increases, molar conductivity increases. The next is a graph from chemical kinetics. You have to write the energy distribution curve showing temperature dependence on the rate of reaction. So how does the graph appear? Along the y-axis, you have the fraction of molecules, and along the x-axis, you have kinetic energy. Then 2 curves should be drawn, is it not? I am just giving you an idea. So, one curve at lower temperature is like this, and the other curve at 10-degree higher temperature is like this. So, if this happens to be the energy of activation, then this particular area under the graph gives you the fraction of molecules reacting at T Kelvin, and this particular area gives you the fraction of additional molecules, is it not? You have to mark all these parts or the areas. So, additional molecules reacting at T plus 10 Kelvin. Okay, so this is a rough graph which forms the answer. Of course, don't forget to write the x-axis and y-axis parameters, without which you do not get any marks. Alright, so the next question, what are coenzymes? This is a question from your surface chemistry, is it not? These are the substances that increase the efficiency of an enzyme. Then name the method used for concentration. Of course, there is one more surface chemistry question, question number 6. Name the shape selective catalyst which converts alcohols directly into gasoline. It is nothing but ZSM5. So, whenever the name is asked, you have to write the name. You cannot give, remember, the formula as an answer. If they specify name, remember the name has to be written. Ninth question is from noble gases. It's a hydrolysis reaction. Because in this reaction you are using 2 water molecules, okay? You are using 2 water molecules. That is why what happens is from XeF6, 4 fluorines are replaced. 2 oxygens come and 2 fluorines remain. So, the answer is XeO2F2. 2 oxygens ಬರುತ್ತೆ, 4 fluorines ಅನ್ನು replace ಮಾಡ್ತದೆ. Okay, 2 more oxygens remain. Then, question number 10 is a D block question. Which element of 3D series has more number of unpaired electrons in the ground state? It is the element chromium. You can write chromium or you can just write Cr because they have not asked the name anta kelilla. So chromium is the answer. Its configuration, outer configuration is 3D 5,4s1. Okay, so maximum 6 unpaired electrons are present. Then define the term racemization, a haloalkane question. Conversion of enantiomer into its racemic mixture is the answer. 12th is a alcohol phenol chapter question. Out of ortho and para nitrophenols, which one is less volatile? It is nothing but para nitrophenol, is it not? Ortho nitrophenol has got intramolecular hydrogen bonding, adrindagi adu jasti volatile ide, but paradalli intermolecular hydrogen bonding iruva karana less volatile ide. So the answer is para nitrophenol. Then one little bit indirect question is from aldehydes ketone chapter. It is mention the role of dry HCl in the addition of alcohols to carbonyl compounds. What does HCl do? It protonates the carbonyl oxygen and thereby it makes the nucleophilic attack on carbonyl carbon easy. So, the role is protonation of carbonyl oxygen making the attack of nucleophile on carbonyl carbon easy. 14th one is a polymer question. Give an example for synthetic biodegradable polyamide copolymer. There are 2 biodegradable polymers, PHBV and nylon 2, nylon 6. Here the answer is nylon 2, nylon 6, okay, because you need a polyamide, the answer is nylon 2, nylon 6. Name the first popular artificial sweetening agent, a question from chemistry in everyday life. The answer is saccharin, okay. Then coming to the part B, 2 mark questions. 16th one is from solids, number of particle calculation in BCC unit cell. We have already discussed that topic. 17th is Henry's law statement. Partial pressure of the gas in vapor phase is directly proportional to the mole fraction of the gas in solution. And what is its mathematical formula? Mathematical formula is P is equal to KH into X, where P is the partial vapor pressure of the gas, is it not? KH is the Henry's law constant and X is the mole fraction of the gas in solution. Okay, so it's better you explain the terms also along with the formula. Alright, then the next 2 mark question is a problem from electrochemistry on Kohlrausch law. Here, limiting molar conductivity of calcium chloride is asked and the values of limiting molar conductivities for the 2 of its ions are given. So, how to solve this problem? First you write the formula. the formula is lambda m naught for calcium chloride is equal to small lambda m naught for Ca2 plus small lambda m naught for Cl minus. There are two Cl minus ions, hence here a 2. So, making use of this formula, you can solve the problem. Remember, you have to write the unit. And what is the unit? It is already there in the question. Okay. The same unit given in the question has to be written. Then, symbolic representation of standard hydrogen electrode is asked. You can write the representation and mention its standard electrode potential value. It is 0. You know it. Okay. What is the role of, see the previous question, 19 and even 18 are from electrochemistry. Question number 20 is from general principles. The role of coke and limestone in the extraction of cast iron using blast furnace. What is the role of coke? It reduces the hematite ore. And what is the role of limestone? It decomposes, producing the flux CaO, which removes the silica gangue in the form of slag. Is it not? Coke is a reducing agent for hematite ore, and limestone produces flux CaO, which removes the gangue silica in the form of calcium silicate slag. The next question from noble gases is, name the noble gas. You have to write the name, not the formula. Name the noble gas which does not have general noble gas configuration NS2NP6. It is helium. Is it not? Helium has the configuration 1s2. So, helium is the answer. Name the commercial source of this gas. The commercial source of helium is nothing but natural gas. 22nd is from halo compounds, Friedel-Crafts reaction of chlorobenzene. So, we have discussed it in electrophilic substitutions. Chlorobenzene reacts with methyl chloride in the presence of anhydrous aluminum chloride catalyst, and it forms what? Ortho and para products, is it not? You have to write a sentence and also you have to give the equation for the reaction. So, the products are, you get two products or you get a mixture of products. One is ortho, the other is para. Ortho product is like this. This is your chlorobenzene, methyl group comes here at the same time. In the other molecule of chlorobenzene, methyl group attacks the para position. So, 1 chloro, 2 methyl benzene and 1 chloro, 4 methyl benzene are the products. How do you prepare propanamine? By Hoffman-bromamide degradation, write the chemical equation. So, in the Hoffman-bromamide reaction, what we do? We start with an amide, we treat it with bromine in NaOH or KOH, and we get a primary amine containing 1 carbon less. Okay, so if you want propanamine, what you have to do? You have to start with the amide containing propyl group, CH3, CH2, CH2, then attach CONH2. Okay, this is now butanamide. treat it with bromine, NaOH, then you get CH3CH2 CH2 NH2, that is propanamine. Okay. Of course, there are byproducts in the reaction. They are Na2CO3 and water. So this is the answer. You can also give the equation for the process. The next question, 24th question, is from Chemistry in Everyday Life. Why soap does not work in hard water? Because hard water contains calcium and magnesium ions which react with the soap, and they form an insoluble gummy mass that sticks to the cloth. So this is the answer. You can also give the equation for the process. I'll take a soap, a sodium soap I have taken. This reacts with the calcium in hard water and it forms insoluble calcium soap, and the sodium ions come out. Okay, so because of this insoluble mass, the gummy mass, the soap fails to work. So you can give the reason and you can also quote the reaction. There is one more question, 25th question from the same chapter. Give an example each for anti-fertility drug. It is norethindrone, or you can also write novestrol, but with the correct spellings. And anionic detergents, you can write sodium lauryl sulfate or sodium dodecyl benzene sulfonate. Okay, so that was about 2 mark questions. Now let us have a look at part C. That is 3 mark questions, inorganic chemistry, part Ninda. First question, leaching of alumina. It has already been discussed in the important concepts. Then the next 27th question, Oswald's process, has been discussed. 28A is how is ozonide oxygen prepared in the laboratory. If you pass a slow and dry stream of oxygen over silent electric discharge, then you get ozone. Oxygen gets converted to ozone. The product is called ozonized oxygen. Equation has been asked. It is 3O2 giving 2O3, a simple reaction, but you have to mention here that delta H naught is positive. Along with the equation, you write delta H naught is positive because this is a non-spontaneous endothermic reaction. So, sign of delta H naught should be given. Next question B. So, A and B both are from the sulfur family or group 16. You can see that intermixing of the groups has not been done. So, complete the equation type question. It is calcium oxide plus water will give you, it's a simple reaction, CaOH twice. Okay, the answer is CaOH twice. 29A from halogen family, B also from the same family. Which is the strongest acid among hydrogen halides? Answer is Hi. Give one reason. in HI, the bond dissociation enthalpy is quite low compared to other hydrogen halides. HI bond dissociation enthalpy is less, therefore its acidic strength is more. Then write the structure of hypochlorous acid. So it was told to you while discussing the important topics that oxoacid structures are important. How do you write now the structure of HOCl? It is very simple. H is attached to oxygen and also a chlorine is attached to the same oxygen. This is the structure of HOCl. Next 3 questions are from D and F block. What are interstitial compounds? When small atoms like carbon, hydrogen, nitrogen are trapped inside the crystal lattices of the metal, interstitial compounds are formed. Write any 2 characteristics. They are inert, okay, they retain the electrical conductivity. Such properties can be written. Then 31st is a sure question, manufacture of potassium dichromate. It has already been discussed. 32nd is a F block question, lanthanoid contraction and its consequence. That is also discussed. 33rd question from coordination chemistry. As expected, one of the complexes is asked. The complex is a nickel complex. Tetracyanidoglycolate complex it is. So it is an expected question. But remember that not just the features, you have to give detailed explanation for this. 34th question, geometrical isomers of a complex are asked. So cis and trans forms should be written. And the coordination number of cobalt there is obviously 6. ಅದರಲ್ಲಿ 4 amine ಮತ್ತು 2 chlorido ligands ಇದೆ. ಹಾಗಾಗಿ coordination number will be 6. Now let us write the isomeric structures. Cobalt in the middle, 4 amine ligands like this, and 2 chlorido ligands facing each other. So this forms the trans form actually. Now how do you make it cis? This is the trans form. To make it cis, I'll put the chlorido ligand here and amine ligand here. So now the 2 chlorido ligands are adjacent to each other, making the complex cis. Next is postulates of Werner's theory, expected question. What is the formula of potassium hexacyanidopherrate? The formula becomes, because the central metal ion is in 3+ form and cyanido ligands totally bear a charge of 6-. So 3 potassium ions are needed. K3FeCN6 is the formula. So this is the formula. Okay, so that was about part C. Coming to part D. Packing efficiency of simple cube, expected one. Next, density of the solid has already been solved. 37A is a question on the colligative property, depression in freezing point. We have discussed the formula already. Here one thing you have to note, that is, see, in this type of problem, the temperature difference can be given either in degree Celsius or Kelvin. If it is given in Kelvin, there is no problem, you take it as such. But in case it is given in degree Celsius, if the temperature difference is given in degree Celsius, please don't convert it to Kelvin, because difference in temperature remains the same in both the scales. Celsius alli Kelvin alli difference temperature idu same irtade, alli conversion na agatya irudilla. Yaude scale alli kodli, you have to substitute that as such. Next, reverse osmosis. When pressure greater than osmotic pressure is applied on solution side, pure solvent flows out of the solution through semi-permeable membrane. Practical utility is in desalination of seawater. 38A is a electrochemistry problem. It is a problem on equilibrium constant. We have discussed the formula already. E naught cell is directly given here. You can see that the value of N is 2 for the problem. Then two methods to prevent corrosion of iron. One is painting the surface of iron, another is coating the surface using more reactive metals like magnesium or zinc. Then as expected, integrated rate equation has come, this time for the zero order reaction. Then which are the two factors responsible for effective collisions? One is the reactant molecules must be properly oriented. Another is reactant molecules must collide with energy equal to or greater than activation energy. Next is a kinetics problem. It's a problem on energy of activation. Here it is given that rate of the reaction doubles. So remember, if the rate doubles, even the rate constant doubles. So indirectly they are saying that the value of K2 by K1 here is 2. Okay, K2 by K1 is given to be 2. Next is our derivation on half-life period of first order reaction. It's an expected question. 41A, differences between lyophilic and lyophobic colloids. You can say lyophilic colloids are stable, reversible. In those colloids, there is an affinity between the dispersed phase and medium. And in lyophobic, they are unstable, irreversible, and there is no affinity. Such differences can be quoted. How does free energy and entropy change during adsorption of gas on solids? Both of them, remember, decrease. Okay, both of them decrease. All right, coming to the last part, 42A, mechanism of SN1 reaction, sure question. There is a sub question. Please read the questions carefully. There will be some sub questions along with the main question. Why tertiary alkyl halides undergo SN1 reaction very fast? The answer is tertiary alkyl halides form the most stable tertiary carbocation. Okay, that is why they undergo the reaction very fast. SN1 reaction agbekidre carbocation form adadu stable irbeku. And tertiary halides in the stable carbocation form agate. So the answer is formation of stable tertiary carbocation. Next, a reaction has been asked that between ethyl bromide and magnesium metal. So it is a Grignard formation reaction, C2H5Br plus Mg in the presence of dry ether gives you C2H5MgBr. It's a simple insertion reaction. Magnesium insert ಆಗ್ತಾ ಇದೆ alkyl group ಮತ್ತೆ bromide ನ ನಡುವೆ. You get ethyl magnesium bromide. Equation and the explanation is expected. 43A is a mechanism already discussed. Next, how is phenol prepared from aniline? First, you have to subject aniline to diazotization. Benzene diazonium chloride sigtade. Then you have to just warm it with water, you get phenol. Both equation and explanation are needed. 44A, reaction of ether with the HI. There what happens is, the bond which has been shown breaks actually, and you get two products. Tertiary butyl group comes out of the molecule, and the products are CH3 thrice Ci. Okay, one of the product is tertiary butyl iodide plus CH3O becomes CH3OH. Methanol is the other product. Next, some molecules are given, phenol and alcohol, and which is more acidic is asked. Of course, phenol is more acidic. Reason we have discussed. Name the enzyme that catalyzes conversion of glucose and fructose to ethanol. It is nothing but zymase. The enzyme is zymase. Certain reactions have been given and their names are asked. First reaction, without any doubt, is a named reaction, Stephen reaction. Second is a named reaction again, Cannizzaro reaction. And third one is a Clemmensen reduction. Please see to it that the spellings are written properly. Next, cross-aldol condensation is asked between benzaldehyde and acetophenone, and the product name is also asked. Let's write the product. You have to give actually the full equation, but let me now write just the product and let me name it. Benzaldehyde and acetophenone are reacting with each other in the presence of dilute alkali. So the product that you get is, this is the benzaldehyde group. It has lost its oxygen. It forms a double bond with the acetophenone group. Acetophenone has lost its two hydrogens. So what remains is CH. And you also have a CO group. Then a benzene ring. Okay, so this is the product. And how do you name it? It is 1,3. Okay, 1,3 diphenyl. There are two phenyl groups. 1,3 diphenyl prop 2-ene 1-one. 1,3 diphenyl prop 2-ene 1-one is the product name. What is decarboxylation? Give an example. You can take say sodium acetate and treat it with soda lime. What happens is you get a hydrocarbon methane. Okay, that may becomes an example for decarboxylation. Next is HVZ reaction. It's a named reaction discussed already. Benzoic acid doesn't undergo Friedel-Crafts reaction. Why? Because benzoic acid binds to the catalyst aluminium chloride. 47A from amines. Write the chemical name and the structure of Hinsberg's reagent. Chemical name is benzene sulfonyl chloride. And what is the structure? The structure is, draw a benzene ring, sulfonyl group and a chlorine atom. So, this is the structure of Hinsberg's reagent. Explain carbylamine reaction 47b by taking ethanamine as an example. So, ethanamine should be treated with chloroform and alcoholic KOH. You get ethyl isocyanide as the product. Equation for the reaction has to be given. Next, aniline is less basic than ammonia. Give reason. It has already been discussed. 48A from carbohydrates. Glucose contains carbonyl groups. You have to give a proof for that. What you can do is you take glucose and make it react with hydroxylamine. You get an oxime. So, that is the proof for it. Glucose contains primary alcoholic group. You take glucose and gluconic acid, treat them with concentrated nitric acid, you get saccharic acid as the product. So, that is the experimental proof for the presence of primary alcoholic group. Hayward structure of alpha D maltose has already been given. Deficiency of which vitamin causes beriberi? It is vitamin B1. What are non-essential amino acids? These amino acids are synthesized in the body. Give an example. You find many examples. For essential, the examples are less. For non-essential, you have many examples like glycine. What is a peptide bond? It is an amide bond formed by the reaction between COOH group and the NH2 group of different amino acids. How many peptide bonds are there in tripeptide? The bonds are only 2. Okay, if the peptide contains n amino acids, remember the peptide bonds will be n minus 1. Okay, next question is from nucleic acid. The question says, what is the name the sugar moiety present in DNA? So, the sugar moiety is beta D 2-deoxyribose. Last question is from polymers. It is on vulcanization of rubber. Explain vulcanization of rubber. What you have to write is, natural rubber is heated with sulfur in the presence of appropriate additives. Sulfur forms cross links at the double bond positions between the rubber chains and makes it stiff. So, this is vulcanization. IUPAC name of isoprene has been asked. It is 2-methyl-1,3-butadiene. And what is its structure? Structure of isoprene is, right, 4 carbons. Second carbon bears a methyl group. First and third carbon have double bonds. Satisfy the valencies using appropriate number of hydrogens. So, this is 2-methyl-1,3-butadiene. And the last question of the question paper is, What are the monomeric repeating units in nylon 6,6? See, in the name 6 and 6, it stands for the number of carbons in the monomers. So, which are the two monomers? They are adipic acid and hexamethylene diamine. Okay, both the monomers have 6 carbons, adipic acid and hexamethylene diamine. Okay, so with that, the question paper, model question paper discussion is over. At the end, I would like to give you a few general instructions. As far as possible, try to write the answers for 1 mark questions on the very first page itself. So, if you write the answers here and there are chances of the evaluator missing them. And also leave at least a 2-line space between the different answers. Put appropriate question numbers, that is very important. First, you write the required number of questions. That is, ಮೊದಲಿಗೆ ಎಷ್ಟು ಬೇಕು ಅಷ್ಟು ಮಾತ್ರ questions ಅನ್ನು ಆನ್ಸರ್ ಮಾಡಿ and choice ಅನ್ನು ಕೊನೆಗೆ if the time permits. ಓಕೆ, ಕೊನೆಯಲ್ಲಿ ಆನ್ಸರ್ ಮಾಡಿ. ಮೊದಲೇ ಎಲ್ಲ ಕ್ವೆಶ್ಚನ್ಸ್ ಆನ್ಸರ್ ಮಾಡ್ತಾ ಹೋದರೆ ಟೈಮ್ ಶಾರ್ಟೇಜ್ ಆಗುವ ಚಾನ್ಸಸ್ ಇರ್ತದೆ. And simple calculators matra allowed, scientific calculators exam ge allow madudilla. Also log and anti-log tables will be provided to you. Now, as I promised in the beginning, I would like to show you how to take log and anti-log by using the logarithm tables. So, I'll take an example. If at all you have a number, say 2.381, how do you take the log? Decimal point na hindugade ಒಂದೇ ಒಂದು ಡಿಜಿಟ್ ಇದೆ, ಹಾಗಾಗಿ ನೀವು 0 ಪಾಯಿಂಟ್ ಅಂತ ಬರಿಬೇಕು. ಓಕೆ, ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ನ ಹಿಂದ್ಗಡೆ 2 ಡಿಜಿಟ್ಸ್ ಇದ್ದರೆ ಆನ್ಸರಲ್ಲಿ ಯು ವಿಲ್ ರೈಟ್ 1 ಪಾಯಿಂಟ್. ಆಲ್ ರೈಟ್, ದೆನ್ ಲೊಗ್ಯಾರಿದಮ್ ಟೇಬಲ್ನಲ್ಲಿ 2, 3ಯ ಸಾಲಲ್ಲಿ 8ನ ಕೆಳಗೆ ವ್ಯಾಲ್ಯೂ ನೋಡಿ ಅದಕ್ಕೆ 1ನ ಮೀನ್ ಡಿಫ್ರೆನ್ಸ್ ಆ್ಯಡ್ ಮಾಡಿ. ಓಕೆ, ದ್ಯಾಟ್ ವಿಲ್ ಗಿವ್ ಯು ದ ಫೈನಲ್ ಆನ್ಸರ್. ಹೀಗೆ ಲಾಗ್ ತೆಗಿಬೋದು. ಸೊ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ನ ಹಿಂದ್ಗಡೆ ಇದ್ದದನ್ನು 1 ಲೆಸ್ ಮಾಡಿ ಬರಿಬೇಕು. 2 ಡಿಜಿಟ್ಸ್ ಇದ್ದರೆ 1 ಪಾಯಿಂಟ್, 4 ಡಿಜಿಟ್ಸ್ ಇದ್ದರೆ 3 ಪಾಯಿಂಟ್. ಇದು ಫಸ್ಟ್ ಸ್ಟೆಪ್. ಮತ್ತು ಲೊಗ್ಯಾರಿದಮ್ ಟೇಬಲ್ನಲ್ಲಿ ಓಕೆ ಎಲ್ಲ ಡಿಜಿಟ್ಸನ್ನು ಇನ್ಕ್ಲೂಡಿಂಗ್ ದ ವೆರಿ ಫಸ್ಟ್ ಡಿಜಿಟ್ ಓಕೆ ನೋಡಿ ಫೈನಲ್ ಆನ್ಸರ್ ಬರಿಬೋದು. ದೆನ್ ಹೌ ಡು ಯು ಟೇಕ್ ಆಂಟಿ-ಲಾಗ್? say you have a number 51.287 okay ಈ ಥರ ನಂಬರ್ ಇದ್ದರೆ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ನ ಹಿಂದ್ಗಡೆ ಇದ್ದದನ್ನು 10 ಪವರ್ ಆಗಿ ಬರಿಬೇಕು. ಆಲ್ ರೈಟ್, ಅದು ಎಷ್ಟೇ ದೊಡ್ಡ ನಂಬರ್ ಇರಲಿ, ಯು ರೈಟ್ ಇಟ್ ಆಸ್ 10 ಪವರ್. ಸೊ ಹಿಯರ್ ಇನ್ ದಿಸ್ ಕೇಸ್ ಇಟ್ ಬಿಕಮ್ಸ್ 10 ಪವರ್ 15. ದೆನ್ ಆಂಟಿ-ಲಾಗ್ ಟೇಬಲಲ್ಲಿ ನೋಡುವಾಗ ಪಾಯಿಂಟಿನ ನಂತರದ್ದು ಮಾತ್ರ ನೋಡಿ. ಓಕೆ, ಡೋಂಟ್ ಸ್ಟಾರ್ಟ್ ಫ್ರಮ್ ದ ಬಿಗಿನಿಂಗ್. ಪಾಯಿಂಟ್ನ ನಂತರದ್ದು ಮಾತ್ರ ನೋಡಿ. 0.28ನ ರೋನಲ್ಲಿ 7ನ ಕೆಳಗೆ ಎಷ್ಟು ಇದೆ ಅಂತ ನೋಡಿಕೊಂಡು ರೈಟ್ ದ ವ್ಯಾಲ್ಯೂ ಹಿಯರ್. ಆ್ಯಂಡ್ ಆಲ್ವೇಸ್ ಆಫ್ಟರ್ ದ ಫಸ್ಟ್ ಡಿಜಿಟ್ ಯು ಪ್ಲೇಸ್ ಯುವರ್ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್. ಆಯಿತಾ, 3 ಸ್ಟೆಪ್ಸ್ ಇದೆ. 10 ಪವರ್ ಬರೆಯೋದು, ಪಾಯಿಂಟ್ನ ನಂತರದ್ದು ಆಂಟಿ-ಲಾಗ್ ಟೇಬಲಲ್ಲಿ ನೋಡೋದು, ಆ್ಯಂಡ್ ಬಂದ ವ್ಯಾಲ್ಯೂಗೆ ಸೇ ಇಫ್ ದ ವ್ಯಾಲ್ಯೂ ಇಸ್ some A, B, C, D, then after A you will place the decimal point. Okay, so with that I would like to end this question paper discussion session. I wish you all the very best for your examinations and thank you.